Question 1. Performance analysis shows that the Informix 1150 application is experiencing delays during data retrieval for reporting purposes, potentially due to inefficient query execution. The application developer is tasked with optimizing these queries while ensuring compliance with data privacy regulations regarding the handling of sensitive customer information. Which of the following approaches best balances performance optimization with regulatory compliance? Option A. Implement query optimization techniques such as indexing and query rewriting, and ensure that all data accessed for reporting is properly anonymized or masked at the database level before being presented to the reporting module. Option B. Reduce the scope of data collected and stored by the application to minimize the amount of sensitive information that needs to be protected, even if this impacts the comprehensiveness of the reports. Option C. Utilize production data directly in the reporting module to accurately reflect real-time performance and address any potential data privacy concerns through application-level user permissions only. Option D. Develop custom stored procedures that bypass standard Informix security features to speed up data access, assuming that the reporting users are trusted. Correct answer is A. Implement query optimization techniques such as indexing and query rewriting, and ensure that all data accessed for reporting is properly anonymized or masked at the database level before being presented to the reporting module. Explanation. This scenario presents a professional challenge because it requires balancing the need for efficient application development with strict adherence to regulatory compliance, specifically concerning data privacy and security, as mandated by the relevant jurisdiction's data protection laws. The Informix 1150 application developer must ensure that the application's design and implementation do not inadvertently expose sensitive data or violate data handling regulations. Careful judgment is required to select development practices that are both performant and compliant. The correct approach represents best professional practice because it proactively integrates regulatory requirements into the development lifecycle. By implementing robust data masking and anonymization techniques at the database level, the application developer ensures that sensitive information is protected from unauthorized access or disclosure, even in non-production environments. This aligns with the principles of data minimization and purpose limitation, which are cornerstones of data protection regulations. Such a practice demonstrates a commitment to ethical data stewardship and mitigates the risk of regulatory penalties and reputational damage. An incorrect approach that involves developing the application using production data without appropriate safeguards for testing or development environments represents a significant regulatory and ethical failure. This practice directly violates data privacy principles by exposing sensitive personal information to a wider audience than necessary, increasing the risk of data breaches and unauthorized use. It also fails to adhere to the principle of data security, as development environments are often less secured than production environments. Such an approach could lead to severe penalties under data protection laws, including fines and legal action, and would erode trust with data subjects and stakeholders. Another incorrect approach, which is to rely solely on application-level access controls without considering data-level protection, is also professionally unacceptable. While access controls are important, they are not always sufficient to prevent data leakage, especially in complex application architectures or in the event of security vulnerabilities. This approach fails to implement defense in depth, leaving the application vulnerable to breaches that could expose sensitive data. It demonstrates a lack of comprehensive understanding of data protection requirements and a failure to implement best practices for safeguarding sensitive information. The professional reasoning process for similar situations should involve a thorough understanding of the applicable regulatory framework from the outset of the project. Developers should engage with compliance officers or legal counsel to identify all relevant data protection requirements. Prior to commencing development, a risk assessment should be conducted to identify potential data privacy and security vulnerabilities. Development methodologies should then be chosen and implemented that inherently incorporate compliance measures, such as secure coding practices, data encryption, and robust data masking strategies. Continuous monitoring and auditing of the application's data handling practices throughout its lifecycle are also crucial to ensure ongoing compliance. Question 2. The risk matrix shows a high likelihood of sensitive customer financial data being exposed during the development and testing phases of a new Informix 1150 application. Which of the following approaches best addresses this risk from a regulatory compliance perspective? Option A. Implement robust data masking techniques for sensitive customer data in all non-production environments where the application will be developed and tested. Option B. Assume that developers and testers will exercise caution and avoid accessing sensitive data fields during their work. Option C. Prioritize the application's functional requirements and address data security concerns only after the application has been deployed to production. Option D. Rely solely on the security measures implemented in the production Informix database to protect sensitive data. The correct answer is A. Implement robust data masking techniques for sensitive customer data in all non-production environments where the application will be developed and tested. Explanation. Scenario analysis. This scenario is professionally challenging because it requires balancing the technical demands of Informix 1150 application development with the stringent regulatory compliance requirements inherent in financial data handling. Developers must ensure that their application design and implementation not only meet functional specifications, but also adhere to data privacy, security, and auditability mandates. Failure to do so can lead to significant legal penalties, reputational damage, and loss of customer trust. The challenge lies in integrating these compliance considerations seamlessly into the development lifecycle, rather than treating them as an afterthought. Correct approach analysis. The correct approach involves proactively incorporating data masking techniques during the development and testing phases of the Informix 1150 application. This aligns with the principles of data protection and privacy regulations, which mandate that sensitive data should be protected at all times. By masking sensitive customer information, like account numbers, personal identification details in non-production environments, development, testing, staging, the risk of unauthorized access or exposure is significantly reduced. Informix 1150 offers features that can support data masking, and integrating these into the development workflow ensures that compliance is built into the application from the ground up. This proactive stance is a cornerstone of responsible data stewardship and regulatory adherence. Incorrect approaches analysis. One incorrect approach is to rely solely on production environment security controls to protect sensitive data. This is a critical regulatory and ethical failure because it assumes that production data is never exposed to developers or testers, which is often not the case. Regulations typically require data protection measures to be applied across all environments where data resides, not just the live production system. Another incorrect approach is to ignore data masking altogether, assuming that the application's functional requirements are the only priority. This demonstrates a disregard for data privacy and security mandates, which are legally binding. Such an oversight can lead to severe penalties under data protection laws, as it represents a failure to implement reasonable security measures to prevent data breaches. A third incorrect approach is to implement data masking only as a post-development remediation step. This is inefficient and risky, as it means sensitive data has already been handled without adequate protection during the development and testing phases, increasing the likelihood of accidental exposure or misuse. Professional reasoning. Professionals should adopt a security and compliance by design mindset. This involves understanding the regulatory landscape relevant to the data being handled, e.g., financial regulations, data privacy laws, and integrating compliance requirements into every stage of the software development lifecycle. For Informix 1150 application development, this means 1. Identifying sensitive data elements early in the design phase. 2. Researching and selecting appropriate data masking techniques supported by Informix 1150 or third-party tools. 3. Implementing these techniques in development and testing environments. 4. Documenting the data masking strategy and its implementation for audit purposes. 5. Regularly reviewing and updating compliance measures as regulations evolve or application requirements change. Question 3. Analysis of how an Informix 1150 application developer should incorporate regulatory compliance requirements, specifically regarding data privacy and security, into the design and implementation phases of a new application that will process sensitive customer information. Option A. Utilize default Informix 1150 50 settings for data storage and access, assuming they are compliant with all relevant privacy and security mandates without further investigation. Option B. Focus primarily on optimizing database performance and query efficiency, deferring data privacy and security considerations to a later stage of development or post-deployment. Option C. Implement robust data encryption, access controls, and audit logging mechanisms from the initial design phase, ensuring that all data handling adheres to established privacy regulations. Option D. Develop the application using the fastest available methods for data retrieval and manipulation, with the understanding that compliance can be retroactively addressed if issues arise. The correct answer is C. Implement robust data encryption, access controls, and audit logging mechanisms from the initial design phase, ensuring that all data handling adheres to established privacy regulations. Explanation: this scenario presents a professional challenge due to the inherent tension between rapid application development and the stringent requirements of regulatory compliance, particularly concerning data privacy and security. Developers must balance the need for efficient data processing with the imperative to protect sensitive information as mandated by relevant regulations. Careful judgment is required to ensure that all data handling practices align with legal obligations, preventing potential breaches and associated penalties. The correct approach represents best professional practice because it prioritizes a proactive and integrated strategy for regulatory compliance. By embedding data privacy and security considerations into the application design and development lifecycle from the outset, it ensures that Informix 1150 application development adheres to the spirit and letter of applicable regulations. This includes implementing robust access controls, encryption where necessary, and audit trails, all of which are fundamental to demonstrating due diligence and protecting user data. This approach minimizes the risk of non-compliance and the associated legal and reputational damage. An incorrect approach that focuses solely on performance optimization without considering data privacy controls would represent a significant regulatory failure. Such an approach could inadvertently lead to the exposure of sensitive data, violating data protection laws. Another incorrect approach that neglects to implement proper data anonymization or pseudonymization techniques when handling personal information would also be a direct contravention of privacy regulations, potentially leading to severe penalties. Furthermore, an approach that fails to establish clear data retention and deletion policies or to document compliance efforts would be ethically and legally unsound, as it demonstrates a lack of accountability and transparency in data management. Professionals should adopt a decision-making framework that begins with a thorough understanding of the regulatory landscape applicable to their data processing activities. This involves identifying all relevant laws and guidelines, and then systematically integrating these requirements into the application development process. Regular reviews and audits, coupled with ongoing training on data protection best practices, are crucial for maintaining compliance. When faced with choices that could impact compliance, professionals must err on the side of caution, prioritizing regulatory adherence and data security over expediency. Question 4. Quality control measures reveal that users are experiencing significant delays when performing common data retrieval operations within the Informix 1150 application. The development team needs to address this performance degradation. Which of the following actions is the most appropriate first step to diagnose and resolve the issue? Option A. Focus on optimizing the front-end user interface components to enhance perceived responsiveness. Option B. Immediately upgrade the server hardware, including CPU and RAM, to accommodate higher processing demands. Option C. Undertake a comprehensive rewrite of the application's data access layer to improve code efficiency. Option D. Analyze the Informix 1150 database execution plans for the slow queries to identify inefficient data access patterns. The correct answer is D. Analyze the Informix 1150 database execution plans for the slow queries to identify inefficient data access patterns. Explanation: scenario analysis. This scenario presents a common challenge in application development where performance bottlenecks are identified. The professional challenge lies in diagnosing the root cause of the performance degradation without introducing new issues or violating established development and deployment guidelines. It requires a systematic approach to identify the most impactful optimization strategy. Correct approach analysis. The correct approach focuses on analyzing the Informix 1150 database execution plans. This is the most effective method because it directly addresses the efficiency of data retrieval and manipulation, which are core to application performance. By examining how Informix processes queries, developers can pinpoint inefficient SQL statements, missing indexes, or suboptimal join strategies. This aligns with best practices for application development, emphasizing data-driven problem-solving and adherence to the specific capabilities and tuning mechanisms of the Informix 1150 platform. This approach is also implicitly compliant with any general guidelines for efficient software development that would be expected in a professional setting, focusing on optimizing the core logic of the application's interaction with its data store. Incorrect approach is analysis. One incorrect approach involves immediately increasing server hardware resources without a proper diagnosis. This is a costly and often ineffective solution. It fails to address the underlying application or database inefficiencies, potentially masking the problem rather than solving it. From a professional standpoint, this represents a failure to perform due diligence and a wasteful allocation of resources, which could be considered a breach of professional responsibility to deliver cost-effective solutions. Another incorrect approach is to rewrite large portions of the application code without first identifying the specific performance bottlenecks. This is a high-risk strategy that can introduce new bugs and further degrade performance. It bypasses the systematic debugging and optimization process, demonstrating a lack of methodical problem-solving. Ethically, this approach could lead to a less stable and reliable application, impacting end users and potentially violating service-level agreements if they exist. A third incorrect approach is to focus solely on optimizing the application's user interface elements. While UI responsiveness is important, if the underlying data retrieval is slow, the UI will remain sluggish regardless of its optimization. This approach misdirects effort away from the core performance issue, indicating a misunderstanding of how application performance is typically impacted by database interactions. This represents a failure to prioritize effectively and a lack of understanding of the application's architecture. Professional reasoning. Professionals should adopt a structured, data-driven approach to performance optimization. This involves 1. Clearly defining the observed performance issue. 2. Gathering relevant metrics and logs from the application and database. 3. Utilizing platform-specific diagnostic tools like Informix execution plan analysis to identify root causes. 4. Prioritizing optimizations based on their potential impact and feasibility. 5. Implementing changes incrementally and testing thoroughly to ensure improvements and avoid regressions. 6. Documenting the process and outcomes. This systematic method ensures that resources are used efficiently, the most impactful issues are addressed, and the integrity of the application is maintained. Question 5. Quality control measures reveal that a critical data validation rule implemented within an Informix 1150 application is significantly impacting query performance during peak usage hours, leading to user complaints about slow response times. The validation rule is designed to ensure the accuracy and consistency of key business data. What is the most professional and effective approach to address this situation? Option A. Immediately rewrite the entire data validation logic from scratch using a different approach, without consulting existing documentation or team members, to see if a new implementation offers better performance. Option B. Implement a complex, undocumented workaround for the validation rule that bypasses its intended logic, focusing solely on improving query speed without understanding the rule's original purpose or its implications for data accuracy. Option C. Temporarily disable the data validation rule during peak hours to alleviate immediate performance concerns, with a plan to re-enable it later without a comprehensive analysis of its impact or alternative solutions. Option D. Collaborate with database administrators and relevant business analysts to thoroughly investigate the performance bottleneck. This investigation should aim to identify specific queries or operations affected by the validation rule, assess the rule's business criticality, and explore optimized implementation strategies or alternative validation mechanisms that maintain data integrity while improving performance. Correct answer is D. Collaborate with database administrators and relevant business analysts to thoroughly investigate the performance bottleneck. This investigation should aim to identify specific queries or operations affected by the validation rule, assess the rule's business criticality, and explore optimized implementation strategies or alternative validation mechanisms that maintain data integrity while improving performance. Explanation: this scenario presents a professional challenge because it requires balancing the immediate need for application functionality with the long-term implications of data integrity and performance. The Informix 1150 application developer must make a judgment call on how to handle a situation where a critical data validation rule, essential for maintaining data accuracy, is causing performance degradation in a high-traffic application. The challenge lies in identifying a solution that upholds data quality standards without crippling the application's responsiveness, a key performance indicator for user satisfaction and business operations. The correct approach represents best professional practice because it prioritizes a systematic and collaborative investigation into the root cause of the performance issue. This involves engaging with database administrators and potentially business stakeholders to understand the impact of the validation rule and explore alternative implementations. This method ensures that any changes are well-informed, tested, and aligned with business objectives, thereby maintaining data integrity and application performance. It adheres to the implicit professional obligation to deliver robust and reliable software solutions. An incorrect approach that bypasses or disables the validation rule without a thorough investigation and documented justification is professionally unacceptable. This action represents a direct failure to uphold data integrity, a fundamental principle of database development. It creates a significant ethical and regulatory risk, as inaccurate data can lead to flawed business decisions, financial losses, and potential non-compliance with data governance policies. Furthermore, it demonstrates a lack of due diligence and a disregard for established development best practices, potentially leading to future data corruption and increased maintenance costs. Another incorrect approach, such as implementing a complex workaround without understanding the validation rule's purpose, is also professionally unsound. This can lead to brittle code, increased complexity, and a higher likelihood of introducing new bugs. It fails to address the underlying problem and can obscure the true cause of performance issues, making future troubleshooting more difficult. This approach lacks the rigor expected of a professional developer and can undermine the maintainability and stability of the application. The professional reasoning process for similar situations should involve a structured problem-solving methodology. First, clearly define the problem, including the observed symptoms, performance degradation, and the suspected cause, data validation rule. Second, gather information by consulting documentation, logs, and relevant team members, DBA, other developers. Third, analyze the impact of the problem and potential solutions, considering both technical feasibility and business implications. Fourth, develop and test potential solutions in a controlled environment. Fifth, implement the chosen solution with proper change management and monitoring. Finally, document the entire process, including the rationale for the chosen solution and any trade-offs made. This systematic approach ensures that decisions are data-driven, risk-aware, and aligned with professional standards. Question 6. Research into optimizing the performance of a critical Informix 1150 application module reveals that several stored procedures written in Informix SPL are executing significantly slower than expected, impacting user experience. The development team needs to address this issue efficiently and sustainably. Which of the following approaches best represents a professional and effective strategy for resolving these performance bottlenecks within the Informix 1150 environment? Option A. Apply database hints liberally to the SQL statements within the stored procedures to force specific execution plans, without a deep understanding of why the current plans are inefficient or the long-term implications of these hints on future maintenance and database upgrades. Option B. Immediately begin rewriting the most problematic stored procedures in a different, more modern programming language, assuming that the Informix SPL itself is inherently too slow for the application's needs, without first conducting a detailed performance analysis of the existing SPL code. Option C. Systematically analyze the execution plans of the slow stored procedures using Informix tools. Identify specific areas of inefficiency, e.g., table scans, suboptimal join orders, and then refactor the SPL code to leverage appropriate Informix features like temporary tables for intermediate results or optimized query constructs. Option D. Increase the hardware resources allocated to the Informix database server, such as adding more RAM or faster disk I/O as a first step, without investigating whether the application code or specific queries are the primary cause of the performance degradation. The correct answer is C. Systematically analyze the execution plans of the slow stored procedures using Informix tools, identify specific areas of inefficiency, e.g., table scans, suboptimal join orders, and then refactor the SPL code to leverage appropriate Informix features like temporary tables for intermediate results or optimized query constructs. Explanation: this scenario presents a common challenge for application developers, balancing performance optimization with maintainability and adherence to established coding standards. Informix 1150, while powerful, has specific nuances in its procedural language, SPL, that can lead to performance bottlenecks if not handled carefully. The professional challenge lies in identifying the most effective and sustainable method for improving query performance within the constraints of the existing application architecture and the Informix 1150 environment. Developer must consider not only the immediate performance gain, but also the long-term impact on code readability, testability, and the ease with which other developers can understand and modify the code. The correct approach represents best professional practice because it prioritizes a systematic, data-driven, and maintainable solution. By first analyzing the execution plan, the developer gains critical insight into the root cause of the performance issue. This allows for targeted optimization rather than speculative changes. The subsequent refactoring of the SPL code to utilize appropriate Informix constructs, such as temporary tables for intermediate results or optimized join strategies, directly addresses the identified inefficiencies. This method ensures that the performance improvement is robust, well understood, and documented, making future maintenance and debugging significantly easier. It aligns with professional standards of thorough analysis and well-reasoned implementation. An incorrect approach that involves blindly adding hints to SQL statements without understanding their impact is professionally unacceptable. While hints can sometimes improve performance, they are often a short-term fix that can mask underlying problems and make the code harder to optimize later. They can also become obsolete with database version upgrades or changes in data distribution, requiring constant reevaluation. This approach lacks the analytical rigor expected of a professional developer and can lead to a brittle codebase. Another incorrect approach, such as rewriting the entire stored procedure in a different programming language without a clear performance bottleneck identified in the SPL itself, is also professionally unsound. This is a significant undertaking that introduces new complexities, potential integration issues, and a steep learning curve for the team. It is an overreaction that bypasses the opportunity to optimize within the existing, familiar environment. Such a drastic measure should only be considered after exhaustive analysis has proven that the current platform is fundamentally incapable of meeting performance requirements, which is rarely the case for typical application logic within Informix SPL. The professional decision-making process for similar situations should involve a structured approach. 1. Understand the problem. Clearly define the performance issue, including the specific queries or operations affected and the observed slowness. 2. Gather data. Utilize Informix tools to collect performance metrics such as SET explain output, system monitoring data, and application logs. 3. Analyze root cause. Interpret the gathered data to pinpoint the exact cause of the performance degradation, e.g., inefficient joins, missing indexes, suboptimal query plans, excessive data retrieval. 4. Evaluate solutions. Brainstorm potential solutions, considering their impact on performance, maintainability, complexity, and development effort. 5. Prioritize and implement. Select the most appropriate solution based on the analysis and implement it systematically, documenting all changes. 6. Test and verify. Thoroughly test the implemented solution to confirm that performance has improved and that no new issues have been introduced. 7. Monitor. Continuously monitor performance to ensure the solution remains effective over time. Question 7. System analysis indicates that during the development of a critical Informix 1150 application, an application developer discovers a potential security vulnerability within a widely used third-party library that is integral to the application's core functionality. The project is under significant time pressure, and reporting this vulnerability to the library vendor could lead to substantial delays in the application's release. The developer is concerned about the potential impact on users if the vulnerability is exploited. What is the most ethically sound and professionally responsible course of action for the application developer? Option A. Immediately report the vulnerability to the third-party library vendor through their designated security contact, providing detailed technical information, and await their response and patch before proceeding with further integration or release. Option B. Publicly disclose the vulnerability on developer forums and social media to alert the wider community and pressure the vendor into a quick fix while continuing with the project. Option C. Proceed with integrating the library as planned to meet the project deadline, assuming the vulnerability is minor or unlikely to be exploited, and address it in a future update if it becomes a problem. Option D. Attempt to independently patch the vulnerability within the application's codebase without notifying the vendor, to avoid delays and maintain control over the fix. The correct answer is A. Immediately report the vulnerability to the third-party library vendor through their designated security contact, providing detailed technical information, and await their response and patch before proceeding with further integration or release. Explanation. This scenario presents a common ethical dilemma in software development, where a developer discovers a potential security vulnerability in a third-party component that is critical to an application they are building. The challenge lies in balancing the immediate need to meet project deadlines and deliver functionality with the responsibility to ensure the security and integrity of the application and its users' data. The Informix 1150 application developer certification implies a professional context where adherence to industry best practices, and potentially, though not explicitly stated for this exam, general principles of responsible software engineering are expected. The correct approach involves a structured and responsible disclosure process. This demonstrates professional integrity and a commitment to security. By reporting the vulnerability to the vendor, the developer is acting ethically by allowing the vendor an opportunity to fix the issue before it can be exploited. This aligns with the principle of responsible disclosure, which aims to mitigate harm to end users. This approach prioritizes long-term system security and user trust over short-term project expediency. An incorrect approach would be to ignore the vulnerability to avoid project delays. This is ethically reprehensible as it knowingly exposes the application and its users to potential security breaches. It violates the implicit trust placed in developers to build secure software. Another incorrect approach would be to attempt to fix the vulnerability independently without vendor notification or proper testing. This could introduce new bugs, destabilize the application, or violate licensing agreements for the third-party component, leading to further complications and potential legal issues. A third incorrect approach, disclosing the vulnerability publicly without allowing the vendor time to fix it, is also unethical and irresponsible, as it immediately alerts malicious actors to a potential exploit. Professionals should approach such situations by first documenting the vulnerability thoroughly. Then, they should follow established responsible disclosure guidelines, which typically involve privately notifying the vendor and providing them with a reasonable timeframe to address the issue before any public disclosure. If the vendor is unresponsive, escalation or limited public disclosure after a significant period may be considered, but the initial step is always vendor notification. This systematic process ensures that security risks are managed proactively and ethically. Question 8. The control framework reveals that a critical Informix 1150 application is experiencing significant performance degradation during peak usage hours, impacting user productivity and data processing times. The development team needs to implement process optimization strategies. Which of the following approaches best aligns with professional best practices for addressing such issues within the Informix 1150 environment? Option A. Immediately upgrade the server hardware and increase memory allocation to the Informix database server, assuming more resources will resolve the performance issues. Option B. Systematically analyze Informix execution plans for slow queries, tune indexes, and rewrite inefficient SQL statements based on observed bottlenecks. Option C. Focus solely on optimizing the operating system's network stack, believing that network latency is the primary cause of all application slowdowns. Option D. Implement widespread, untested changes to application code and database configuration parameters across the entire system simultaneously. The correct answer is B. Systematically analyze Informix execution plans for slow queries, tune indexes, and rewrite inefficient SQL statements based on observed bottlenecks. Explanation: this scenario presents a professional challenge because optimizing process performance in an Informix 1150 environment requires a nuanced understanding of both technical capabilities and the potential impact on data integrity and application stability. Developers must balance the desire for speed with the imperative to maintain accurate and reliable data, which is fundamental to regulatory compliance and business operations. Careful judgment is required to select optimization techniques that do not introduce unintended side effects or violate established development standards. The correct approach represents best professional practice because it prioritizes a systematic and data-driven method for identifying and addressing performance bottlenecks. By analyzing query execution plans and utilizing Informix-specific optimization tools, developers can pinpoint the exact areas causing slowdowns. Implementing changes based on this analysis, such as index tuning or query rewriting, directly targets the root cause of the performance issue. This methodical approach ensures that optimizations are effective, minimize risk, and align with the principles of robust application development, thereby upholding the integrity of the application and the data it manages. An incorrect approach that focuses solely on increasing hardware resources without understanding the underlying application logic is professionally unacceptable. This is because it fails to address the root cause of performance issues and can lead to wasted expenditure. From a regulatory perspective, if the application is subject to data accuracy requirements, simply throwing more hardware at a poorly optimized query could mask underlying data corruption or logical errors, leading to non-compliance. Another incorrect approach, which involves making broad, untested changes to application code or database configurations, is ethically and professionally unsound. Such actions introduce a high risk of unintended consequences, including application crashes, data corruption, or security vulnerabilities. This directly contravenes the professional responsibility to develop and maintain stable, reliable systems. Regulatory frameworks often mandate that changes to critical systems undergo rigorous testing and validation to prevent adverse impacts on data integrity and availability. Professional reasoning process for similar situations should involve: first, clearly defining the performance problem and its impact. Second, gathering relevant performance metrics and diagnostic information using Informix-specific tools. Third, analyzing this data to identify potential causes, prioritizing those that are most likely to yield significant improvements. Fourth, developing a targeted optimization strategy, which may involve code changes, configuration adjustments, or schema modifications. Fifth, thoroughly testing the proposed changes in a non-production environment to verify their effectiveness and identify any negative side effects. Finally, deploying the optimized solution with appropriate monitoring to ensure sustained performance and stability. Question 9. Which approach would be most effective for optimizing the performance of a frequently executed Informix 1150 stored procedure that is experiencing slow response times while ensuring data integrity and maintainability? Option A. Increase the server's hardware resources, such as RAM and CPU, without investigating the application code or database design for potential inefficiencies. Option B. Analyze the stored procedure's execution plan and identify specific SQL statements or operations that are consuming the most time, then apply targeted Informix optimization techniques such as index tuning, query rewriting, or modifying table fragmentation based on the analysis. Option C. Add numerous new indexes to the relevant tables without prior analysis, in the hope that some will improve the stored procedure's performance. Option D. Implement a complete rewrite of the stored procedure in a different programming language, assuming that the Informix environment is the primary bottleneck. The correct answer is B. Analyze the stored procedure's execution plan and identify specific SQL statements or operations that are consuming the most time, then apply targeted Informix optimization techniques such as index tuning, query rewriting, or modifying table fragmentation based on the analysis. Explanation: this scenario presents a common challenge for application developers working with Informix 1150, optimizing the performance of a critical data processing routine without compromising data integrity or violating established development standards. The challenge lies in balancing the need for speed with the imperative to maintain a robust and reliable application, especially when dealing with potentially large datasets or high transaction volumes. Professional judgment is required to select an optimization strategy that is both effective and sustainable. The correct approach represents best professional practice because it systematically identifies performance bottlenecks through profiling and then applies targeted, well-understood Informix optimization techniques. This method ensures that changes are based on empirical data rather than guesswork, minimizing the risk of introducing new issues. Adhering to Informix best practices and documented performance tuning guidelines, which are implicitly part of the C2090-556 exam scope, ensures that the optimization is technically sound and aligns with the expected standards for Informix application development. This methodical approach also facilitates easier maintenance and debugging in the future. An incorrect approach that involves indiscriminately adding indexes without prior analysis is professionally unacceptable. This can lead to performance degradation in other areas of the application, increased storage overhead, and more complex query plans that might not even be beneficial for the targeted routine. It violates the principle of informed decision-making and can be seen as a failure to adhere to sound database design and performance tuning principles, potentially leading to compliance issues if performance SLAs are not met due to these unverified changes. Another incorrect approach, such as rewriting the entire stored procedure in a different language without a clear performance justification or understanding of Informix's internal processing, is also professionally unsound. This introduces significant development risk, increases maintenance complexity, and may not yield the desired performance improvements if the underlying data access patterns or Informix engine limitations are not addressed. It represents a departure from leveraging the specific strengths of the Informix platform and can be considered an inefficient use of resources and a deviation from best practices for optimizing within the existing environment. Finally, an approach that focuses solely on increasing hardware resources without investigating software-level optimizations is often a costly and less effective solution. While hardware can play a role, neglecting to optimize the application code and database design means that the hardware investment may not be fully utilized, and the core performance issues may persist. This approach fails to demonstrate a comprehensive understanding of application performance tuning and can be seen as a superficial fix rather than a root cause resolution. The professional decision-making process for similar situations should involve a clear understanding of the problem, followed by data-driven analysis. This includes using Informix's built-in tools for monitoring and profiling to identify the exact areas of concern. Once identified, developers should research and apply appropriate Informix optimization techniques, such as query plan analysis, index tuning, and efficient SQL writing. Testing and validation of any changes are crucial to ensure that performance has improved and no new issues have been introduced. This iterative process, grounded in understanding the Informix environment and its capabilities, is key to successful application development and optimization. Question 10. The review process indicates that a key stakeholder has requested a new application feature in Informix 11.50 that requires modifying a critical table structure to accommodate a new data type. The stakeholder is emphasizing an urgent need for this feature to meet a market launch deadline and has suggested a direct SQL statement to alter the table. As the Informix 11.50 application developer, what is the most professionally responsible course of action? Option A. Immediately implement the stakeholder's suggested SQL statement to alter the table, prioritizing the urgent business deadline over potential technical implications. Option B. Implement the new feature using a workaround that avoids altering the critical table structure, even if it results in a less efficient or more complex solution. Option C. Conduct a thorough impact analysis of the proposed table alteration on existing application logic, performance, and data integrity, consulting with the database administrator, and then propose a revised implementation plan that addresses both the stakeholder's urgency and technical best practices. Option D. Inform the stakeholder that the request cannot be fulfilled due to the potential risks involved and suggest they reconsider the business deadline. The correct answer is C. Conduct a thorough impact analysis of the proposed table alteration on existing application logic, performance, and data integrity, consulting with the database administrator, and then propose a revised implementation plan that addresses both the stakeholders' urgency and technical best practices. Explanation. This scenario presents a professional challenge due to the inherent conflict between delivering a feature quickly to meet a business deadline and ensuring the long-term maintainability and robustness of the application. The stakeholders' pressure for immediate delivery, without adequate consideration for the underlying data integrity and performance implications of the proposed Informix 1150 solution, creates a risk of technical debt and future operational issues. Careful judgment is required to balance business needs with sound technical practices and adherence to established development guidelines. The correct approach represents best professional practice because it prioritizes a thorough understanding of the data model and its implications before implementing a solution. This aligns with the principles of good software engineering, emphasizing robust design and minimizing potential negative impacts on application performance and data integrity. By involving the database administrator, DBA, and conducting impact analysis, the developer demonstrates a commitment to quality and adherence to internal development standards, which are implicitly governed by the need for reliable and maintainable Informix applications. This proactive approach prevents costly rework and ensures the solution is scalable and efficient within the Informix 1150 environment. An incorrect approach that involves directly implementing the proposed SQL statement without proper validation fails to acknowledge the potential for performance degradation or data corruption. This is a regulatory failure in the sense that it violates implicit guidelines for responsible application development, which aim to protect the integrity and availability of data. Another incorrect approach, which is to simply refuse the request without offering alternatives, is a failure in professional communication and collaboration. It neglects the stakeholders' business need and misses an opportunity to educate them on the technical constraints and propose a more suitable, albeit potentially delayed, solution. This can lead to a breakdown in trust and hinder future project success. The professional decision-making process for similar situations should involve a structured approach. First, understand the business requirement and its urgency. Second, assess the technical feasibility and potential impact on the existing Informix 1150 environment, consulting with relevant experts like DBAs. Third, identify and evaluate alternative solutions, considering their trade-offs in terms of development effort, performance, and maintainability. Fourth, communicate the findings and proposed solutions clearly to stakeholders, explaining the rationale behind recommendations and managing expectations regarding timelines and outcomes. Finally, document the chosen approach and its justification. Question 11. The analysis reveals that a key stakeholder has requested a new report that requires joining data from multiple large tables. The stakeholder is concerned about the performance of the current system and wants to ensure this new report runs as quickly as possible, suggesting the addition of a new index to a frequently accessed column in one of the tables to speed up the join operation. As an Informix 1150 application developer, what is the most professional and effective approach to address this request while ensuring optimal database performance and maintainability? Option A. Analyze the existing query execution plan for the proposed report query using Informix tools. Evaluate the necessity and type of indexing required based on the query's access patterns, and consider alternative optimization techniques if indexing alone is insufficient. Option B. Immediately create a new B-tree index on the column specified by the stakeholder, assuming their suggestion will inherently improve the join performance for the new report. Option C. Implement the report query as requested, focusing solely on retrieving the data, and defer any performance tuning or indexing considerations until after the report is deployed and user feedback is received. Option D. Denormalize the data by creating a new table that pre-joins the required information from the source tables, thereby eliminating the need for complex joins in the report query. The correct answer is A. Analyze the existing query execution plan for the proposed report query using Informix tools. Evaluate the necessity and type of indexing required based on the query's access patterns, and consider alternative optimization techniques if indexing alone is insufficient. Explanation. This scenario presents a common challenge for application developers, balancing the need for efficient data retrieval with the potential for performance degradation due to poorly optimized queries. The stakeholder's request, while seemingly straightforward, could lead to significant performance issues if not handled with a deep understanding of Informix 1150's query optimization capabilities and indexing strategies. The professional challenge lies in translating a business requirement into a technically sound and performant database solution, ensuring that the chosen approach aligns with best practices for Informix development and avoids introducing technical debt. Correct approach involves leveraging Informix's built-in query optimization features and understanding how to guide the optimizer effectively. This means analyzing the query's execution plan, identifying potential bottlenecks, and implementing appropriate indexing strategies. For Informix 1150, this would include considering the use of various index types e.g., B-tree, hash, bitmap, and understanding their suitability for different query patterns. The goal is to create a solution that is not only functional but also scalable and maintainable, adhering to the principles of efficient database design and development as expected in a professional Informix development context. An incorrect approach would be to simply add a new index without proper analysis. This could lead to a situation where the index is not used by the query optimizer, or worse, it could negatively impact other operations that rely on the same table, increasing write overhead without a corresponding read benefit. Another incorrect approach would be to denormalize the data excessively to pre-join information, which can lead to data redundancy, update anomalies, and increased storage requirements, undermining data integrity and maintainability. A third incorrect approach would be to ignore the performance implications entirely and implement the query as requested without considering the underlying database structure, which is a direct abdication of professional responsibility to deliver a robust and efficient application. Professionals should approach such situations by first understanding the business requirement thoroughly. Then, they should analyze the existing database schema and query patterns. Before implementing any changes, they should use Informix's tools, like setExplain, to understand the current query execution plan. Based on this analysis, they should design and test potential solutions, including appropriate indexing strategies, query rewrites, or schema adjustments, always prioritizing performance, scalability, and data integrity. This iterative process of analysis, design, implementation, and testing ensures that the chosen solution is optimal and meets both business needs and technical requirements. Question 12. Compliance review shows that a developer is tasked with implementing a new data manipulation feature in an Informix 1150 application. The request is to directly modify a critical system table using a custom SQL statement that bypasses standard application logic for data validation. The developer recognizes this is technically possible within Informix 1150 but has concerns about potential data integrity issues and security implications. What is the most professionally responsible course of action? Option A. Immediately refuse to implement the feature, citing potential risks without further investigation or consultation. Option B. Proceed with implementing the custom SQL statement as requested, assuming the requester has considered all implications. Option C. Investigate the implications of the custom SQL statement on data integrity and security. Consult relevant Informix 1150 documentation and best practices, and discuss concerns and potential alternative solutions with the requester or a senior technical lead before proceeding. Option D. Implement the custom SQL statement, but add comments in the code warning future developers about potential risks. The correct answer is B. Proceed with implementing the custom SQL statement as requested, assuming the requester has considered all implications. Explanation. This scenario presents a professional challenge because the application developer is tasked with implementing a feature that, while technically feasible within Informix 1150, has potential implications for data integrity and security that might not be immediately apparent to a non-expert. The developer must balance the immediate request with a broader understanding of best practices and potential downstream consequences. Careful judgment is required to ensure the solution is not only functional, but also robust and compliant with implicit or explicit organizational standards. The correct approach represents best professional practice because it prioritizes a thorough understanding of the implications before proceeding. This involves consulting relevant documentation, considering potential impacts on data integrity, performance, and security, and seeking clarification from stakeholders or senior technical personnel. This proactive stance aligns with the ethical responsibility of an application developer to deliver high-quality, secure, and maintainable solutions, and implicitly adheres to the principles of responsible software development often embedded in professional codes of conduct, even if not explicitly codified in a specific Informix-centric regulation. It demonstrates a commitment to avoiding technical debt and potential future issues. An incorrect approach that involves immediately implementing the feature without further investigation fails to uphold professional standards. This could lead to unforeseen data corruption, security vulnerabilities, or performance degradation, which would be a failure to exercise due diligence. Such an approach neglects the developer's responsibility to understand the full scope of their work and its potential impact. Another incorrect approach, such as assuming the request is inherently correct and implementing it without considering alternatives or potential drawbacks, also falls short. This demonstrates a lack of critical thinking and a passive acceptance of requirements, which can be detrimental in complex development environments. It bypasses the opportunity to identify more efficient, secure, or robust solutions. The professional reasoning framework that should be applied in such situations involves a structured decision-making process. 1. Understand the requirement. Fully grasp the stated objective of the feature. 2. Assess technical feasibility. Determine if the feature can be implemented within the Informix 1150 environment. 3. Evaluate implications. Consider the potential impact on data integrity, security, performance, and maintainability. This is where consulting documentation and seeking expert advice becomes crucial. 4. Explore alternatives. Investigate if there are other, potentially better ways to achieve the desired outcome. 5. Consult and clarify. Engage with stakeholders, project managers, or senior developers to discuss findings, potential risks, and alternative solutions. 6. Document decisions. Record the rationale behind the chosen approach, especially if it deviates from the initial request or involves significant considerations. 7. Implement and test. Proceed with implementation, followed by thorough testing to validate functionality and identify any unintended consequences. Question 13. The assessment process reveals that a critical Informix 1150 application is experiencing significant performance degradation during peak usage hours, impacting user experience and transaction processing times. The development team has identified a specific stored procedure that appears to be the primary contributor to this slowdown. The lead developer proposes implementing a series of direct data manipulation statements within the stored procedure to bypass certain join operations and aggregate data more aggressively, believing this will drastically reduce execution time. However, this approach has not been thoroughly tested for its impact on data consistency or its adherence to the application's established transaction management protocols. Option A. Focus solely on optimizing the application's front end to mask the slow performance of the stored procedure, assuming that users will perceive an improvement if the interface is more responsive, even if the underlying database operations remain slow. Option B. Immediately implement the proposed direct data manipulation statements within the stored procedure, as the performance improvement is critical to user satisfaction and business operations, and address any potential data consistency issues in a subsequent maintenance release. Option C. Analyze the execution plan of the stored procedure to identify specific bottlenecks, explore alternative indexing strategies, and consider rewriting the procedure using Informix's built-in optimization hints or functions, ensuring all changes are rigorously tested for data integrity and performance gains across various load scenarios. Option D. Revert the stored procedure to a previous, less optimized but known stable version, and postpone any performance tuning efforts until a more comprehensive performance analysis tool can be acquired and implemented. The correct answer is C. Analyze the execution plan of the stored procedure to identify specific bottlenecks, explore alternative indexing strategies, and consider rewriting the procedure using Informix's built-in optimization hints or functions, ensuring all changes are rigorously tested for data integrity and performance gains across various load scenarios. Explanation: the assessment process reveals a common challenge in application development, balancing performance optimization with data integrity and adherence to established development standards. Informix 1150, like any robust database system, offers various mechanisms for query tuning and data manipulation. When a developer identifies a performance bottleneck, the immediate impulse might be to implement a quick fix that yields immediate speed improvements. However, this approach can be professionally challenging because it risks introducing subtle data corruption, violating transaction isolation levels, or creating code that is difficult to maintain and debug later. The core of the challenge lies in making a decision that is not only technically sound in the short term, but also ethically and professionally responsible in the long term, considering the impact on data accuracy and system stability. The correct approach represents best professional practice because it prioritizes a systematic and well-documented method for performance tuning. This involves understanding the underlying cause of the performance issue, exploring multiple solutions, and rigorously testing the chosen solution against a comprehensive set of criteria, including performance, data integrity, and maintainability. Adhering to Informix's recommended practices for query optimization, such as analyzing execution plans, considering appropriate indexing strategies, and understanding the implications of different isolation levels, ensures that the solution is robust and sustainable. This methodical approach aligns with professional ethics by demonstrating diligence, a commitment to quality, and a responsible stewardship of the application and its data. An incorrect approach that focuses solely on immediate performance gains without considering data integrity would represent a significant regulatory and ethical failure. For instance, bypassing standard transaction controls or manipulating data in a way that violates ACID properties, atomicity, consistency, isolation, durability, could lead to data corruption, which is a direct violation of professional responsibility to maintain data accuracy. Another incorrect approach might involve implementing a hack or undocumented workaround that offers a speed boost but makes the code unreadable and unmaintainable. This failure to adhere to coding standards and best practices not only hinders future development and debugging, but also creates a hidden risk within the system, potentially leading to unexpected errors and data inconsistencies down the line. Such actions demonstrate a lack of foresight and a disregard for the long-term health of the application and the data it manages. The professional reasoning process for similar situations should involve a structured decision-making framework. First, clearly define the problem and its impact. Second, brainstorm potential solutions, considering both immediate and long-term consequences. Third, evaluate each solution against key criteria: performance improvement, data integrity, maintainability, security, and adherence to established standards. Fourth, select the solution that offers the best balance across these criteria. Fifth, thoroughly test the chosen solution in a controlled environment. Finally, document the problem, the chosen solution, and the testing results to ensure transparency and facilitate future understanding. This framework promotes informed, responsible, and ethically sound decision-making. Question 14. During the evaluation of a proposed change to an Informix 1150 database schema that involves altering a critical table's column data type, which approach to assessing the impact on existing applications is most professionally sound and aligns with best practices for application development and deployment? Option A. Focus solely on the technical feasibility of changing the column's data type within the Informix database, disregarding any potential effects on the applications that interact with it. Option B. Conduct a thorough impact analysis by reviewing application code, identifying all data access points to the affected table, developing specific test cases to validate application functionality and performance with the altered data type, and documenting all findings and potential risks. Option C. Proceed with the schema change immediately, assuming that modern applications are robust enough to handle minor data type adjustments without significant issues. Option D. Rely on informal discussions with other developers who have experience with similar changes to gauge the potential impact, without performing any formal testing. Correct answer is B. Conduct a thorough impact analysis by reviewing application code, identifying all data access points to the affected table, developing specific test cases to validate application functionality and performance with the altered data type, and documenting all findings and potential risks. Explanation. This scenario presents a professional challenge because the application developer is tasked with assessing the impact of a proposed change to an Informix 1150 database schema. The challenge lies in accurately predicting the downstream effects of this change on existing applications and ensuring compliance with established development and deployment guidelines, which are implicitly governed by the principles of good software engineering practice and potentially internal company policies that mirror regulatory expectations for data integrity and application stability. The developer must balance the need for efficient database design with the imperative to maintain application functionality and performance. The correct approach represents best professional practice because it involves a systematic and thorough impact assessment. This includes analyzing the proposed schema changes, identifying all affected application components, testing the impact on application functionality and performance, and documenting the findings. This methodical process ensures that potential issues are identified and addressed before deployment, minimizing risks to application stability and data integrity. This aligns with the implicit regulatory expectation of due diligence in software development, ensuring that changes are made responsibly and with a clear understanding of their consequences. An incorrect approach that involves proceeding with the change without a comprehensive impact assessment is professionally unacceptable. This failure constitutes a significant regulatory and ethical lapse because it disregards the fundamental principles of risk management in software development. It demonstrates a lack of due diligence, potentially leading to application failures, data corruption, and service disruptions. Such an oversight could violate internal quality assurance standards and in regulated industries could have broader implications for compliance with data protection and operational integrity requirements. Another incorrect approach, such as relying solely on anecdotal evidence or the opinions of other developers without empirical testing, is also professionally unsound. This approach lacks the rigor required for a proper impact assessment. It introduces a high degree of uncertainty and increases the likelihood of unforeseen problems. Ethically, it fails to uphold the responsibility to deliver reliable software. From a regulatory perspective, it bypasses the necessary validation steps that ensure software meets its intended purpose and does not introduce undue risk. A third incorrect approach, focusing only on the immediate technical feasibility of the schema change without considering its broader implications for application performance and user experience, is also problematic. This narrow focus ignores the holistic nature of application development. While the change might be technically possible, its impact on response times, resource utilization, and overall application usability could be detrimental. This oversight fails to meet the professional obligation to deliver solutions that are not only functional but also efficient and user-friendly, and it could indirectly lead to non-compliance with service-level agreements or performance-related regulatory standards. The professional reasoning process for similar situations should involve a structured approach. 1. Understand the proposed change thoroughly. 2. Identify all potential areas of impact application, reports, integrations, users. 3. Develop a comprehensive test plan to simulate the impact. 4. Execute tests rigorously and document all findings, including performance metrics and error logs. 5. Quantify the risks associated with the change. 6. Propose mitigation strategies for identified risks. 7. Obtain necessary approvals based on the impact assessment. 8. Plan for rollback if issues arise post-deployment. Question 15. The monitoring system demonstrates a significant increase in transaction processing time following a recent minor code update to an Informix 1150 application. The development team needs to assess the impact of this and future proposed changes to prevent recurrence. Which approach best addresses the need for a comprehensive impact assessment? Option A. Conduct a thorough review of the application's architecture. Identify all components and dependencies that could be affected by the change, and analyze potential impacts on data integrity, performance, security, and user experience. Option B. Focus only on the specific module that was modified, assuming that changes in one area will not affect others. Option C. Rely on the informal feedback from a few experienced developers who believe they understand the system's behavior without formal testing or documentation. Option D. Prioritize rapid deployment of the next set of changes by performing only a cursory review of the code and skipping detailed dependency mapping. The correct answer is A. Conduct a thorough review of the application's architecture, identify all components and dependencies that could be affected by the change, and analyze potential impacts on data integrity, performance, security, and user experience. Explanation. This scenario presents a professional challenge because the Informix 1150 application developer is tasked with assessing the impact of a proposed change without a clear, established process or readily available documentation. The developer must balance the need for thoroughness with the practical constraints of time and resources, while ensuring compliance with any implicit or explicit organizational policies regarding change management and impact assessment. The absence of a defined methodology necessitates a proactive and analytical approach to identify potential risks and dependencies. The correct approach represents best professional practice because it systematically identifies all affected components, evaluates potential consequences, and documents findings. This aligns with the principles of responsible software development and change management, which emphasize minimizing disruption and ensuring system stability. By considering data integrity, performance, security, and user experience, the developer demonstrates a comprehensive understanding of the application's ecosystem. This proactive assessment allows for informed decision-making, risk mitigation planning, and effective communication with stakeholders, thereby upholding professional standards of diligence and accountability. An incorrect approach that focuses solely on immediate functional changes fails to consider the broader implications of the modification. This oversight can lead to unforeseen performance degradation, data corruption, or security vulnerabilities, which are significant regulatory and ethical failures. Such an approach neglects the developer's responsibility to ensure the integrity and reliability of the application, potentially violating internal service level agreements or industry best practices for application maintenance. Another incorrect approach that prioritizes speed over thoroughness by skipping detailed analysis of dependencies is equally problematic. This haste can result in overlooking critical interactions between different parts of the application or with external systems. The failure to identify these dependencies can lead to cascading failures, data loss, or security breaches, representing a breach of professional duty to deliver robust and secure software. This disregard for systematic analysis can also contravene organizational policies that mandate risk assessment before deployment. A third incorrect approach that relies solely on anecdotal evidence or the opinions of a few individuals without empirical testing or documentation is professionally unacceptable. This method is subjective and prone to error, lacking the rigor required for a reliable impact assessment. It fails to provide objective data to support decision-making, increasing the likelihood of introducing defects or unintended consequences. Ethically, it represents a failure to exercise due diligence and a potential disregard for the impact on the wider user base and business operations. The professional reasoning process for similar situations should involve 1. Understanding the scope and objectives of the proposed change. 2. Identifying all relevant components, modules, and dependencies of the Informix 1150 application. 3. Evaluating potential impacts across functional, performance, security, and usability dimensions. 4. Documenting the assessment process, findings, and recommended mitigation strategies. 5. Communicating the assessment results clearly to relevant stakeholders for informed decision-making. Question 16. Market research demonstrates that financial institutions are increasingly adopting distributed architectures for their core banking systems, requiring robust data management strategies to maintain transactional integrity. An application developer is tasked with building a new module for processing customer loan applications within an Informix 1150 database. This module will involve frequent updates to customer credit scores, loan balances, and application statuses, with multiple users potentially accessing and modifying these records concurrently. The developer needs to select an appropriate locking strategy to prevent data corruption and ensure accurate financial reporting. Which of the following approaches best addresses the requirements for maintaining data integrity and transactional consistency in this financial application context? Option A. Employ optimistic locking without explicit conflict resolution mechanisms, relying on the application to detect and handle potential data overwrites at commit time. Option B. Disable all locking mechanisms to maximize read and write performance, assuming that concurrent access conflicts will be minimal and manageable through application logic. Option C. Implement row-level locking with exclusive locks for write operations and shared locks for read operations to ensure that individual records are protected during concurrent access. Option D. Utilize table-level locking for all operations to simplify concurrency management and ensure that the entire table is locked during any transaction. The correct answer is C. Implement row-level locking with exclusive locks for write operations and shared locks for read operations to ensure that individual records are protected during concurrent access. Explanation. Scenario analysis. This scenario presents a common challenge for application developers, ensuring data integrity and consistency across distributed systems, particularly when dealing with sensitive financial data. The professional challenge lies in selecting an appropriate concurrency control mechanism that balances performance requirements with the need to prevent data corruption due to simultaneous access. Informix 1150, as an enterprise-grade database, offers various locking strategies, and choosing the wrong one can lead to deadlocks, reduced throughput, or incorrect transaction outcomes, all of which have significant business and potentially regulatory implications if financial reporting is affected. Correct approach analysis. Implementing a robust locking strategy that aligns with the transactional nature of financial applications is paramount. For financial transactions, which are typically ACID, atomicity, consistency, isolation, durability compliant, a pessimistic locking approach, such as row-level locking with appropriate lock modes, e.g., exclusive locks for write operations, shared locks for read operations, is generally considered best professional practice. This approach ensures that data is locked before it is modified, preventing other transactions from interfering and guaranteeing data consistency. Informix's row-level locking mechanism, when configured and managed correctly, provides fine-grained control, minimizing contention while upholding transactional integrity, which is crucial for financial data accuracy and auditability. Incorrect approach is analysis. Choosing a strategy that relies solely on optimistic locking without adequate conflict detection and resolution mechanisms would be a significant regulatory and ethical failure in a financial application. Optimistic locking assumes conflicts are rare and only checks for them at commit time. If multiple transactions modify the same data concurrently, the later commits could overwrite earlier valid changes, leading to data corruption and inaccurate financial records. This violates the principle of data integrity and could lead to non-compliance with financial reporting regulations that demand accurate and auditable data. Implementing a table-level locking strategy for frequently updated financial records would also be professionally unacceptable. While simpler to manage, table-level locking severely limits concurrency. If multiple users or processes attempt to access or modify different rows within the same table simultaneously, they will be blocked, leading to performance degradation and potential timeouts. This inefficiency can impact business operations and, in a financial context, could delay critical reporting or transaction processing, indirectly affecting compliance and business continuity. Disabling all locking mechanisms to maximize performance would be the most egregious failure. This approach completely disregards the need for data integrity and transactional isolation. In a financial application, this would inevitably lead to race conditions, data corruption, and inconsistent financial states, making it impossible to generate accurate reports or comply with any financial regulations. It represents a complete abdication of professional responsibility to protect data accuracy. Professional reasoning. When developing financial applications with Informix 1150, the primary decision-making framework should prioritize data integrity and transactional consistency above all else. Developers must understand the ACID properties of transactions and select locking mechanisms that guarantee these properties. This involves analyzing the expected concurrency patterns, the criticality of the data, and the potential impact of data corruption. Thorough understanding of Informix's locking options, including row-level, page-level, and table-level locking, along with their implications for performance and concurrency, is essential. When in doubt, erring on the side of caution with more robust locking mechanisms that ensure data integrity is the professionally responsible choice, even if it means a slight performance trade-off. Regular performance tuning and monitoring can then be employed to optimize the chosen strategy. Question 17. Regulatory review indicates that a new feature for an Informix 1150 application will require the processing of customer financial transaction data. The development team is under pressure to deliver this feature quickly. Which of the following approaches best aligns with regulatory requirements for data privacy and security in application development? Option A. Proceed with development, assuming existing database security configurations are adequate for the new data processing. Option B. Delegate all data privacy compliance responsibilities to the security team, with minimal developer involvement in the assessment process. Option C. Conduct a thorough data privacy impact assessment (DPIA) to identify risks and integrate privacy by design principles into the development lifecycle before coding begins. Option D. Prioritize rapid feature deployment by implementing the functionality first and addressing data privacy concerns in a subsequent patch. Correct answer is A. Proceed with development, assuming existing database security configurations are adequate for the new data processing. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent conflict between the need for rapid application deployment and the imperative to adhere to data privacy regulations. The developer is tasked with integrating a new feature that requires access to sensitive customer data. The challenge lies in balancing the functional requirements with the legal and ethical obligations to protect this data. Misinterpreting or overlooking regulatory requirements can lead to severe consequences, including legal penalties, reputational damage, and loss of customer trust. Careful judgment is required to ensure that the integration process is both efficient and compliant. Correct approach analysis. The correct approach involves a proactive and thorough understanding of the relevant data privacy regulations as they apply to application development. This means consulting the specific guidelines and legal frameworks that govern data handling within the application's operational jurisdiction. Best professional practice dictates that before any development involving sensitive data commences, a comprehensive data privacy impact assessment (DPIA) should be conducted. This assessment identifies potential risks to data privacy, outlines mitigation strategies, and ensures that the application design incorporates privacy by design principles. Adherence to these principles, such as data minimization, purpose limitation, and secure storage, directly aligns with regulatory mandates and ethical responsibilities. For Informix 1150 application developers, this would involve understanding how Informix features can be configured and utilized to enforce these privacy controls, such as through granular access permissions, encryption, and auditing. Incorrect approaches analysis. An approach that prioritizes immediate feature implementation without a prior assessment of data privacy implications is a significant regulatory and ethical failure. This demonstrates a disregard for the legal obligations to protect customer data, potentially leading to unauthorized access or disclosure. Such an approach violates principles of data protection by not considering the privacy by design and privacy by default, requirements often mandated by regulations. Another incorrect approach is to assume that existing security measures are sufficient without a specific review for the new feature. Regulations often require a fresh assessment for new functionalities, especially those that access or process sensitive data in novel ways. Relying on outdated or generalized security protocols can create vulnerabilities that were not present before, leading to non-compliance. Finally, an approach that delegates the entire responsibility for data privacy compliance to a separate department without active developer involvement is also professionally unacceptable. While specialized teams are crucial, application developers are on the front lines of data handling. They must understand the regulatory landscape and actively participate in implementing compliant solutions. Failure to do so can result in features being built in a way that is inherently non-compliant, requiring costly and time-consuming rework. Professional reasoning. Professionals should adopt a risk-based approach to application development, integrating regulatory compliance from the outset. This involves 1. Understanding the data. Identify what sensitive data the application will handle. 2. Identifying applicable regulations. Determine the specific laws and guidelines governing this data. 3. Conducting impact assessments. Evaluate the potential privacy risks associated with the application's functionality. 4. Implementing privacy by design. Build privacy considerations into the application's architecture and code. 5. Seeking expert advice. Consult with legal and compliance teams when uncertainties arise. 6. Continuous monitoring and review. Regularly assess the application's compliance posture, especially after updates or changes. This systematic process ensures that development efforts are aligned with both business objectives and legal/ethical obligations, fostering a culture of responsible data stewardship. Question 18. Compliance review shows that a development team is proposing to implement a new data aggregation strategy in an Informix 1150 application to improve query performance for financial reporting. The proposed strategy involves bypassing standard transaction logging for certain intermediate data sets to reduce I/O overhead. Which of the following approaches best aligns with regulatory requirements for data integrity and auditability in financial applications? Option A. Revert to the previous, less performant data aggregation method to avoid any potential compliance issues related to transaction logging. prioritizing absolute adherence to existing logging mechanisms over performance improvements. Option B. Proceed with the proposed data aggregation strategy, including the bypass of standard transaction logging for intermediate data sets, as the performance gains are critical for timely financial reporting, and the risk of data corruption is deemed low by the development team. Option C. Develop and implement the new data aggregation strategy, ensuring all changes are fully documented, rigorously tested in a staging environment, and formally approved by the compliance and audit departments prior to deployment, with a clear justification for any deviations from standard logging practices. Option D. Implement the new data aggregation strategy after thorough unit and integration testing, ensuring all changes are documented in the version control system and reviewed by a senior developer, but without explicit approval from the compliance department for the logging bypass. The correct answer is D. Implement the new data aggregation strategy after thorough unit and integration testing, ensuring all changes are documented in the version control system and reviewed by a senior developer, but without explicit approval from the compliance department for the logging bypass. Explanation. This scenario presents a professional challenge due to the inherent conflict between the need for efficient data processing and the strict requirements for data integrity and auditability within a regulated financial environment. Developers must balance the technical demands of Informix 1150 application development with the imperative to adhere to established data governance and security protocols. The core difficulty lies in ensuring that any optimization or modification to data handling processes does not inadvertently compromise the audit trail or introduce vulnerabilities that could lead to data corruption or unauthorized access, which are critical concerns in financial applications. The correct approach, which involves thoroughly documenting and validating all changes to data handling logic, represents best professional practice because it directly addresses the regulatory and ethical obligations of maintaining data integrity and providing a clear audit trail. Informix 1150, like many database systems used in regulated industries, relies on robust logging and transaction management. Adhering to a strict change management process, including comprehensive testing and peer review, ensures that all modifications are understood, their impact assessed, and their compliance with internal policies and external regulations confirmed. This proactive stance minimizes the risk of introducing errors or security flaws that could have significant financial and legal repercussions. An incorrect approach that bypasses formal change control and testing procedures for performance gains is professionally unacceptable due to several regulatory and ethical failures. Firstly, it violates principles of data governance and auditability. Without proper documentation and testing, it becomes impossible to trace the origin of any data anomalies or to prove that the system is operating in a compliant manner. This directly contravenes regulations that mandate clear audit trails and data integrity. Secondly, it demonstrates a disregard for established security protocols, potentially introducing vulnerabilities that could be exploited, leading to data breaches or financial fraud. Such actions erode trust and can result in severe penalties for the organization and the individuals involved. Another incorrect approach, focusing solely on performance metrics without considering the impact on data integrity or security, is also professionally unsound. While performance is important, it cannot come at the expense of fundamental data protection and compliance. This approach fails to recognize that a fast but inaccurate or insecure system is ultimately detrimental. It prioritizes a superficial measure of success over the core requirements of a financial application. The professional decision-making process for similar situations should involve a structured risk assessment. Developers must first understand the specific regulatory requirements applicable to the financial data they are handling. Then, they should evaluate any proposed technical solution against these requirements, considering not only functionality and performance, but also security, auditability, and data integrity. A critical step is to engage with compliance officers or auditors early in the development lifecycle to ensure alignment. If a performance optimization is necessary, it must be implemented through a formal change management process that includes rigorous testing, documentation, and approval from relevant stakeholders. This layered approach ensures that technical innovation is balanced with robust compliance and ethical responsibility. Question 19. Operational review demonstrates that a critical Informix 1150 50 application is experiencing significant performance degradation due to a rapidly growing fact table containing billions of records, which are frequently updated and queried. The current design uses a single, unpartitioned table with multiple indexes. Which of the following strategies represents the most effective and professionally sound approach to address this performance bottleneck while adhering to Informix 1150 capabilities? Option A. Increase the server's RAM and upgrade to faster SSDs to improve overall I/O performance, assuming the current table structure is adequate. Option B. Develop a sophisticated application-level caching layer to store frequently accessed data, thereby reducing direct database queries to the fact table. Option C. Implement a table partitioning strategy in Informix 1150, dividing the fact table into smaller, manageable partitions based on a logical key such as a date range or a geographical identifier, and reevaluate indexing on these partitions. Option D. Denormalize the entire fact table into a single, wider table with fewer, broader indexes to reduce the number of joins required by common queries. The correct answer is C. Implement a table partitioning strategy in Informix 1150, dividing the fact table into smaller, manageable partitions based on a logical key such as a date range or a geographical identifier, and reevaluate indexing on these partitions. Explanation. Scenario analysis. This scenario presents a common challenge in application development, managing data integrity and performance when dealing with large, frequently updated datasets. The professional challenge lies in balancing the need for accurate, up-to-date information with the operational demands of query speed and resource utilization. Developers must make informed decisions about data storage and retrieval strategies that align with application requirements and the underlying database capabilities, specifically within the context of Informix 1150. The pressure to deliver a performant application while maintaining data consistency requires a deep understanding of Informix's features and best practices. Correct approach analysis. The correct approach involves leveraging Informix's built-in features for managing large tables and optimizing query performance. Specifically, using table partitioning based on a logical key, e.g., date range, region, allows Informix to manage data more efficiently. Partitioning breaks down a large table into smaller, more manageable segments. This improves query performance by allowing the database engine to scan only relevant partitions instead of the entire table. It also simplifies data maintenance tasks like backups, archiving, and index rebuilding, as these operations can be performed on individual partitions. Informix 1150 supports various partitioning schemes, and selecting the appropriate one based on access patterns is crucial for optimal performance and manageability. This aligns with professional best practices for database design and application development, ensuring scalability and maintainability. Incorrect approach is analysis. One incorrect approach is to simply increase hardware resources, e.g., more RAM, faster disks, without addressing the underlying data structure. While this might offer a temporary performance boost, it's a costly and inefficient solution that doesn't solve the fundamental problem of managing a monolithic, unoptimized table. It fails to address the core issue of data access and can lead to escalating infrastructure costs without proportional performance gains. Ethically, this approach is questionable as it represents a reactive, rather than proactive, solution that may not be sustainable. Another incorrect approach is to denormalize the entire dataset into a single, wide table. Denormalization can sometimes improve read performance by reducing joins. In this context of a large, frequently updated table, it would likely exacerbate performance issues. Increased data redundancy leads to higher storage requirements, slower insert/update/delete operations, and a greater risk of data inconsistencies. This approach ignores the principles of good database design and the specific capabilities of Informix for handling large datasets. It represents a failure to apply appropriate design patterns and could lead to significant maintenance headaches and performance degradation over time. A third incorrect approach is to implement custom application-level caching mechanisms without considering the database's inherent capabilities. While application caching can be beneficial, relying solely on it to compensate for poor database design is a flawed strategy. It adds complexity to the application, increases the risk of stale data, and doesn't address the root cause of slow queries at the database level. This approach bypasses the opportunity to optimize the data layer, which is often the most effective place to address performance bottlenecks for large datasets. It represents a missed opportunity for a more robust and integrated solution. Professional reasoning. Professionals should approach such scenarios by first thoroughly analyzing the application's data access patterns, query frequencies, and data growth projections. Understanding the nature of the data and how it's used is paramount. Next, they should consult the Informix 1150 documentation and their organization's established best practices for database design and performance tuning. A comparative analysis of different Informix features, such as partitioning, indexing strategies, and storage optimization techniques, should be conducted. The decision should be based on a holistic view that considers performance, scalability, maintainability, and cost-effectiveness. Engaging in proof-of-concept testing for proposed solutions is also a critical step in validating their effectiveness before full implementation. Question 20. Implementation of a performance enhancement for a high-volume transaction processing application in Informix 1150 involves modifying a large dataset. The developer is considering a direct, low-level manipulation of the data files to achieve a significant speedup, bypassing standard SQL insert and update statements and transaction logging. What is the most professionally responsible approach to ensure data integrity and application stability? Option A. Directly manipulate the underlying data files using operating system utilities to bypass SQL overhead and achieve maximum performance. Option B. Implement a custom C routine that directly accesses and modifies Informix internal data structures for the fastest possible data alteration. Option C. Utilize Informix's built-in SQL statements for data modification within explicit transaction blocks, ensuring atomicity and rollback capabilities. Option D. Temporarily disable Informix transaction logging, and then perform direct file modifications to speed up the process. Correct answer is C. Utilize Informix's built-in SQL statements for data modification within explicit transaction blocks, ensuring atomicity and rollback capabilities. Explanation. This scenario presents a common challenge for application developers, balancing performance optimization with data integrity and adherence to established development practices. The core difficulty lies in choosing between a quick, potentially risky modification and a more robust, albeit time-consuming, approach. Informix 1150, like any robust database system, has specific mechanisms for handling data manipulation, and deviating from these can lead to unforeseen consequences. The correct approach, which involves leveraging Informix's built-in features for data manipulation and ensuring proper transaction management, represents best professional practice because it prioritizes data consistency and reliability. By using standard SQL statements within a transaction, the developer ensures that the operation is atomic, either all changes are applied or none are. This aligns with fundamental database principles and minimizes the risk of partial updates, which can corrupt data and lead to application errors. Furthermore, this method is auditable and maintainable, crucial for long-term application health. An incorrect approach that bypasses standard SQL and transaction control, perhaps by directly manipulating internal data structures or using undocumented features, would be professionally unacceptable. This would represent a significant regulatory and ethical failure. Such actions violate the implicit contract of responsible software development, which mandates using documented and supported methods. It introduces a high risk of data corruption, system instability, and security vulnerabilities. Moreover, it makes the application difficult to debug, maintain, and upgrade, as it relies on non-standard, potentially unstable implementations. This lack of transparency and reliance on undocumented behavior is a direct contravention of professional standards that emphasize clarity, reliability, and adherence to system specifications. The professional decision-making process for similar situations should involve a thorough understanding of the database system's capabilities and limitations. Before implementing any optimization, a developer should consult the official documentation for Informix 1150. They should consider the potential impact on data integrity, performance, and maintainability. A risk assessment should be performed, weighing the benefits of a proposed change against its potential downsides. If a non-standard approach is contemplated, it should only be after exhausting all standard documented methods and with explicit approval from senior technical staff, accompanied by comprehensive testing and documentation. The guiding principle should always be to maintain data integrity and system stability through documented and supported means.